Right now we've got all the major structures done, and one thing left is what you see here, the ripper on the back of the bulldozer. This piece is a single shank pneumatic ripper, and what this thing does is it gets pushed into the ground by the pneumatic system and then drags open like a big ditch into the ground. It's a system with lots of hydraulics, but mostly it's just a primitive big hook that pulls into the ground. We're just going to start modeling this. As you can see, I just started off with a box, positioned it correctly, pretty much like we start every single object. Now, it is one of the more difficult parts. The reason for that is there's a ton of detail and a lot of separate parts. I might even say this is the most complex part on the bulldozer. If you look at the pictures, like the reference picture of the ripper, you can see that it's just, wow, one big mess of wires and metal plates. I'm just going to start off by creating one of the plates that make up the bottom part of the ripper. And there's the main flat part, and then there's a sort of extra part that comes out on top, which I'm working on right now, that has a few holes for attachment to the pneumatic system. As you can see, I used a few insets to get that rounded shape in there, and now I'm using a few swift loops to also get the correct shape down. And this part might look solid, but it's actually made up out of several plated parts that are put together. You can see these are two plates, and then they're filled up with more plating in between. I'm going to move these around so that I can get my wires looking a bit cleaner right here. And when that's done, I'm going to create a hole in there. And this hole purpose is so that I can create one rounded hole on the inside there for the pneumatic system to attach to. Go. And here I'm doing a few insets and extrudes. Might look like a square, but we all know when that gets rounded, because of the flow of the wires, it will look like a perfect circle. We have these two separate parts now. It looks okay, but they look a little bit too rounded. Fix that up by adding a few extra edges, and now we're going to create the inside. Starting with a plate here, I don't need to add thickness to this because you will never see the edges. I just need to add these plates on the inside so that it's actually closed off. Do a few of them really close together. There we are. That will give some thickness, and then I can just attach this together. That done, I'm going to start creating another part of the bottom of the ripper. There's an interesting shape on the inside, which actually has like an oval, almost egg-shaped hole in the middle. And this will require a little bit of interesting modeling. And this plate is attached to the top of this blue beam that I'm working on. And the plate then extends towards the center and moves towards the front of the ripper. Also at the back, there's a sort of an arc shape that is open. And this arc shape is probably for pneumatic wires to go through. And this is where the egg/oval shape that I was talking about, I'll call it an egg shape from now on because I think that's what it is where this shape sits. You can see I'm moving these wires around. There we are. Looks a bit like an egg, I think, so. Moving these slightly. Right. Just really gotta tweak this until it looks right and then open it up, delete it. Now we gotta see what this looks like when I add symmetry, because I'm pretty sure that this shape will be a little bit too wide. First off, I'm gonna add a loop around that using cut. Cut is easier than using connect because connect wouldn't have the same distance around everything. See, there's a little problem by creating a triangle there, but that's easily fixed with a use of target weld. Like that. Okay. And I feel like this part's a little bit too thick, it's a bit too wide, so I'm moving that in. Now you can see there's a slight problem where it's not aligning with the frame anymore. We'll fix that later. Move this out towards the back. Right now we're just going to concentrate on creating the shape of the ripper itself. The way it attaches to the back of the body is something for later on. Some more extensions here. And another one there. And I'm doing this because, well, there's another sort of arc rounded shape at the back there. You can see this is quite an intricate wire that I'm actually creating here. And I'm just doing this in a flat surface before I start adding thickness to it to just avoid problems. Then I'm taking one of these parts and duplicating it over there, and the reason for that is I immediately have a part with some nice thickness to it. Then just position it correctly. Extrude that a little bit more, scale it down, so it just follows the shape nicely. I can remove some edges that are not needed, and then just continue pulling out more geometry. Connect these up together to create a nice loop that runs around the outside that will make sure that the shape is rounded like a half circle on the end instead of a flat part. So that looks good. Duplicating that over there. And now I need to, of course, follow this semi-arc shape on the inside. It's not going to be too hard. Make sure to rotate these parts a little bit so that they sit perpendicular with the edge they're touching. Then I'm going to align that one. And there we are. I'm detaching that one to use on the inside on the egg shape. I'm just going to do the same thing. Select the border, rotate it perpendicular with the edge, and then shift move it to the correct position, rotate it again, and go around all the way like that. I think that's the easiest way to work on this part. You could say that I could start by shift moving the open edges from the plane on top, but I'm not going to do that because, as I said, this thing is built up out of separate parts. There are a lot of plates that are welded together, and I prefer to build them up out of separate parts myself then. So this is starting to look more interesting. I need to add thickness to that green plate, so that's what I've done. Add a shell modifier to it. And then I'm attaching it to this part. Well, the shell modifier, I'm not sure if I'm going to leave that. First, I need to work a bit on the global shape. If I need to move two parts at the same time, I prefer to attach them into one single object. And then I move this one down, but of course the normals are flipped, so I hit the flip button, and that fixes them at the bottom. And there we are. I'm going to select the borders for everything here, and then shift move those down so that I can actually add some thickness. Now I've covered up this rounded side here, not too hard, just shift moving and then welding things together. With that done, we have the basic shape for our ripper at the bottom done. There are some more details that need to be done here. I need to take this plate and add it on top as an extra layer there. I think it's just more armor, whatever. Add some extra cuts to define the shape better. Those cuts done, I just need to fix this one over here. All right, that looks about right. Need to add a few more edges to get it looking just the way I want. Weld a few that are not needed, but then add an extra one to fix the problem with the non-quads over there. And there we are. That looks like the plated shape I need. Time to add the thickness in, and don't forget to not to add thickness on the part where the symmetry will be welding it together. But this was just like a multi-layered area. There were some plates on top of each other, so that's what I'm doing. You can see in the back, I created a nut there also. Same system I've been using all along. Add some nice detail. And then here, this is an interesting mounting bracket for some hydraulics as well. I think one of the main hydraulic pistons attaches to this area. This is just starting from a cylinder, deleting half, and then modeling on. So using an inset here to get that rounded shape in there. That looks okay. Then delete the bottom. It's a trick I do to add some temporary geometry to make sure that the inset works just the way I want. Then there's some extra geometry here. This looks like it goes down to a triangular shape. This is some reinforcement for this bracket. Since I said the hydraulics are attached to this, a lot of force will be applied to this part. And that's why you want this to be extra sturdy. That's why they add some extra mounting brackets on the side instead of just that one single upstanding part. So adding some extra geometry all over. I think that looks almost okay. It just needs a cylinder in the center here that will look like it's the axle used to attach to the hydraulic system. Moving that to the inside, and then cloning it so I can use it on the outside again. This one's a bit smaller. And then of course performing an inset here, an extra inset, one extra inset, then doing an extrude to get some depth in there. And that should be about it for that part. Then of course, take this part, edit it slightly. Bevel to get the right shape in there. This is just looking at reference, and it's the same thing I've been doing to cylinders all along. That looks about okay. And of course an inset to make sure those edges smooth correct. And a few more extrudes and insets, and have it finally connect to the center. And add some Swift loops. That will be too tedious to add with just using bevel. And then attach this part together. Okay, so that looks about right, except for a small detail here. And this detail has a few nuts attached to it. I think this is some sort of fastening mechanism, not sure what it is exactly. Move that inside, that out. Of course, add the edges for the smoothing. Then take this nut, scale it down because it's quite a bit too big. Do the random rotations. Yeah, just make sure it doesn't look too uniform. And that one's done, so I'm attaching it as well. Okay, this entire part is done. So I'm adding it to the main part of the ripper on the other side. Look at that, it's starting to look quite interesting already. We still need to add quite a few more details. There are some extra brackets here as well. So that's what I'm going to model. It's kind of similar to the other one, but not entirely the same. So I'm just going to start over. This method is the same, but the rest is pretty different. Here we are. Another rounded part here. Move that in like that. And perform the inset and the extrude. Like so. The other side. Do just an inset, another one. I'm not exactly sure what this part is. I think it's some sort of component of the pneumatic system. There's this sort of canister in the center, and then there's this funky little shape comes out of it. I'm drawing it with an auto grid so that I can just simply rotate it and get it into the correct position. Lining it, there we are. There's this sort of L-shaped little piece of tube that comes out, and I really don't know what it is, but it looks interesting enough because it's some rounded shapes, some smaller shapes, all combined together. So I definitely want that in there. I'm going to use a fillet here. Liking that one. Fillet is a bit tricky because you're best to use tie pins to get the exact fillet amount that you want. Right, it's set to renderable so we can see what it exactly does. See, it looks kind of like a straw or something. That's the reason I like it. There we are. I think it'll look better like this. On the reference, it was more like this instead of a filleted shape. So that's what I'm going to do. All right, that looks about good. And then we're just going to attach this part together here. And delete the insides. There, delete. And it's slightly rotated, which is also interesting because most of these parts on the bulldozer are straight. There you are, it looks nice. Okay, we're going to move on to a next big critical component of the Ripper, which is the actual shank and its extending mechanism itself. There's two big metal components, the big bracket at the bottom, and then there's the part where the shank actually extends from, which is what I'm creating here. It's also quite complex in terms of shape. So we're going to follow the same approach. It's tried and tested, starting with a box, then extruding the simple main shapes to get it to look right. Here we are. Scale that slightly down. Okay. Extend that one as well. And then move it in. There we have that rounded shape in there. Right. Add some edges where I think we're going to be needing them. And one remark here is I'm not really following the civilian blueprints. Once again, the military version does look a bit different from the civilian version. I think it's a bit stronger, a bit more armor. And so we're just going to follow that in terms of keeping things accurate. Right. So doing a small extrude here. Moving these around to get the rounding right. And right now I'm going to do an inset here. Why? Well, you'll see right away there's a big interesting part that extends out of that one. It's rounded on one side, so that's why I need an inset. Just preparing work for the base to extrude that thing from. And I think that's about right. So selecting these, and I'm going to perform an inset on them because I think everything should be rounded nicely. Just got to make sure that where the edges sit really close together, that I go back in and fix things up slightly. Move that up. These edges here, they look a little bit crooked, so I'm going to move these around just to keep things clean. And I'm actually going to use these that run around as a sort of control for the smoothing. I'm selecting all of these and performing an extrude. So at the base, and then it gets a lot bigger, but it sort of rotates. So once again, this is a pretty tricky shape. This sort of part, it extrudes from the main plate and then rotates to turn into a mounting bracket for the big pneumatic cylinders. And I've got to make sure that the edges are all working here. Adding some extra edge here for control. And with that done, I have a big triangle in the center there, but we can remove that one. That one's definitely fixable. I've removed the triangles from positions where I prefer not to have them. I do another extrude here. I gotta open up these parts because, well, there's a big ring that runs around the entire part. Aligning them with that axis and snapping them up. I'm gonna do the same thing here. Snapping them correctly. Of course, don't forget to delete the inside before you can actually start welding stuff. Weld these together. Same trick at the top. And of course we can't forget to add our loop where those extra edges are. Seems almost right. I'm just going to use target weld to weld them into position again. Okay. Just taking these loops, moving them up to the top to make sure they're aligned. And with that done, I can use this one and extrude it. Extrude this towards the center. And this part, of course, will be mirrored for the symmetry. And then here's the big extension that extrudes that will form the eventual mounting brackets. There's also an interesting shape here. I'm using an extra inset and then just positioning these verts around until I get that sort of capsule oval shape in there. Then using a bridge to connect them, and then again performing an inset on the inside. Some control edges were also added there, but we're not showing that since it's pretty much logic. Okay, so I'm selecting these. These at the back and performing an extrude. Need to add extra edges. Then once again, I'm doing an extrude here at the bottom. And you can start telling that this shape is really, really complex. It's a plate with lots of extensions and everything. And as far as I could tell, this was not created out of separate parts. I really looked at the reference a lot, and I decided that the best thing to do was to create this out of a single part because it looks more interesting. It's also a more interesting challenge, so it should be should learn more from doing this. And there's a separate part that attaches to this one that I just extruded. And it's this is a separate part, and it sits at the other side. And make sure that the bottom bracket for the ripper is clamped between these two plates so that they can be attached together. You can see that rounded part from the one we just finished up. There's actually going to be an axle running through that will stick through the both sides of the part we're working on right now. So taking these, performing an inset, adding some extra loops. And yeah, that plate doesn't extend towards the back of that boxy area we just extruded. It actually looks like this. So another box part here. Once again, I'm not doing everything in a single part, just whatever is necessary. This is separate as well. And this is some sort of extra thing at the back. I have no clue why they made this part so complex, but we're going to model it anyway. There's a cylindrical shape there, which I created by simply doing extrude and scaling some parts. By now you should also get a pretty good feeling for how I go about creating cylindrical parts that extend from square parts. You gotta make sure that your loops run around correctly, and I use the scale tool a lot when I'm doing this because it makes sure that I can do uniform operations on two separate selections. So there we are. I can select these. Once again, inset, which works better than using a connect or a swift loop in the case of a rounded part like this half cylinder. Adding some extra edges here. Gonna open that one up because why? Well, there's just simply another extrude here. Makes for more geometrical detail. Select these things, weld them up with the correct threshold, and then add an extra line here. And then do the same welding trick. Sometimes it's just easier to select everything, hit weld, and adjust the threshold so you're sure that certain points are welded and the ones that shouldn't be welded are ignored. Okay, so that part at the back there I think is also okay. Starting to look complex, but we're still definitely not there with this part. Let's just see what it looks like with symmetry. Everything seems to check out with the symmetry, so we're going to continue with some more details. there's this little connecting plate that connects that front part with the semi-cylinder to the back part. And it looks a little wonky how it's actually attached, but this is the way it looks in the reference, so we're going to create it the same way. Need to make sure to delete the open sides that you can't see, and then add a few more extra edges to control the smoothing. It looks a little bit too rounded, so I added a few more extra edges there. That was that. Then we continue with another detail here, which is just a cylinder. And this cylinder sort of sticks out from the back. And I think this is a sort of fastening system because they have this weird little pin through them that I might create later on. Then we go back to the top, or as I mentioned, that's where the pneumatic cylinders attach. So I created this box here, and I'm creating a cylinder, deleting half of it, and then we're going to work on attaching these together to form a single unit that will serve as the attachment bracket for the pneumatic cylinder. So that big, how should I call it, U-shaped profile that we just created is where these plates will be mounted into. So it's a combination of quite a few plates. Selecting these, and we're going to perform an inset on them to get the rounding right. Then delete the inside. These need to be rotated slightly. Move them in. And with that done, I'm going to select this side, scale it flat, and then move it over there. This looks really strange, but it's exactly how it's done in the reference, so I'm trying to mimic that. Then I'm using Connect to add an extra edge here, moving it against it with edge constraint and then moving it back out to completely align it, which is a trick I use a lot. And then there's a few extra cylinders here that sit in the center, which will be the actual parts that attach to the pneumatic cylinders. So we have this part over here, just a rounded part. I'm going to do a few insets here. Extrude it a little bit. Add some extra loops. And then I'm going to select these. Extrude them a little bit more. What you can see what I'm trying to do here is create a sort of rounded plating that follows along that cylinder to close it off. Very intricate combination of shapes. It's half rounded, the rest is open. And then I want to go back here at the bottom and create another, let's say it's the ends of the axles that connect these two big brackets together, the two main parts. And this is a shape that will be used a few more times on the rest of the ripper at the back. It's a cylinder with this sort of triangular shape extruded out of it at the end. And they put a few bolts on it then. And I think this is some sort of removable lock nut or fastener that they put on the end of an axle that can be removed quickly for maintenance and to take things apart. It's slightly chamfered around the edges. There is a rectangular part on one side, and this rectangular part is what actually holds this thing into place and prevents it from moving. Positioning this right, you'll see right away how it works. There we go. And these two extrude towards the bottom. There you are. So you can see that green part, it can't rotate anymore because it's held into place by these two things. Move that open slightly. Add a few more connects because it's just quicker to do it this way instead of using Swift Loop. Once again, mirrored actions. And then, of course, some nuts are added on top to be able to remove that part so that you can rotate the lock nut. And it's used also at the top there for this mounting part. It's slightly smaller though, so moving this in a little bit, nothing too difficult. like that. And it's used again on the inside of these mounting parts. Slightly rotated, positioned somewhere like that. I'm going to extend these a bit. And once I have them in position, just leave them at that. I'm not going to attach them, just going to leave them like that. Okay, so next part on the list is the actual shank for the Ripper itself, which is the hook that pulls open the earth when it gets dragged through by the bulldozer. And this thing is supposed to be sturdy because it should withstand some really tough rock. I remember reading that these bulldozers are used in commercial and civilian use to drag open like a ground that have a lot of volcanic rock in there, which is really hard and tough to farm on. So just doing a few extrudes and positioning the points correctly, making sure that I have a nice curve in there, like that. Okay. Something like that. I think I need another subdivision there, and I need to space them apart a little bit more so it looks better. Okay, this looks about okay. And it goes all the way to the top. Then I'm going to select. First I need to make sure that these are exactly positioned right, because if the curve isn't correct, then it's going to look a bit sloppy. So I need to make sure that works right. Okay, so I'm deleting one half because I want to model this symmetrical. Performing an inset to get the rounding right on it. Adding an extra edge here. And then I'm going to perform an inset here because some added detail is created there. It's actually a hole that goes through this thing. There we are. And then just shift move that, put it on the 0 position. There we are. One hole running through. Fix out the top part after the inset I performed there. Set the pivot right. Then add a symmetry modifier just to have a look at what it looks like. And it looks way too fat, so might need to adjust that a little bit. Okay, this is the tip of the Ripper, the shank. And this tip is like an extra part which I think they can replace since it probably gets the most punishment. As you can see, it's been reduced a little bit in terms of thickness, the overall Ripper, which is just a little bit of scaling. So okay, we continue with the tip. Start with a box here. I'm gonna close that up again, perform an inset. Makes more sense like that. Shoot this inwards. Like so. Like that. I'm gonna get this to fit nicely with the parts that sit around it. Okay. Add these extra edges. Once I think this is about okay, I'm going to start attaching it. First, need to move these around a little bit to get the shape slightly more interesting. Also, there's a little hole in there. Need to make sure to align that after using the loop tools. There we are. Snapping things. That hold on, I need to make sure that I finish up the inside. An inset to make sure it's smoothed correctly. I'm going to perform a chamfer here. Well, an extrude, which works better. Like that. Okay, this part's okay, so I attach it. Then there's a sort of an extra part that is, well, the military version. It's a really strange shape. It's really rounded and smooth and curving compared to other parts that are on this bulldozer. And the two extreme parts of it seem to be like they originate from a cylinder. So I'm going to create a cylindrical mesh here and use that as a starting point for this actual object. Go connect. Rotate that to get things to line up nicely. Once again, it's a complex wire, so I'm going to start doing this as a flat surface and work on the flat surface before I actually start to add depth and thickness to it. Well, it has thickness, so I need to make sure I always do drag selections when working on it in side view. But I'm not going to start modeling it in 3 dimensions just yet. I'm trying to get this right first. You see, this sort of looks like a, how do I call this, a dog bone shape with 2 round parts and a connecting curved part on the center. Really, it's probably just another protection part for the shank. And I'm making sure that I'm getting the curve in there nicely. Alright, so another extrude here. Wire looks slightly messy. We can get to fixing that. And even then, it's in a flat surface, so it doesn't matter so much. Right, so I think that's okay. So I'm extruding this part towards the center, so it can get used for symmetry. And I want to get these approximately the same size. This really is one of the nastiest parts on the bulldozer, I think. Really, because it's so undefined and so smooth. It's unlike most of the other parts. Again, doing an inset here. Don't forget to fix up the inside where the symmetry lines meet. We are. And then just align those to the 0 axis. And I'm moving these around slightly to get the rounding in there a little bit better. It's also to add some extra extruded detail in there. See, I'm selecting all of these and then performing an extrude, which creates some extra geometry for me to work with. So I want to align this stuff. Lines being a little bit annoying. Yeah, there we are. That looks better. Moving these around slightly. Now I need to adjust all of these to follow the curve that I want in there. Just tweaking the points. Okay, when the curve is done right, I need to extrude some more at the top there. This tends to extend for quite far. I know this part, now that you look at it, this is probably where a lot of the punishment on the shank itself will happen. So I think they need to be able to take this off and replace it. Of course, I forgot a smoothing line here, so gotta add that. I think that looks about okay. We can delete a lot of the inside because you'll never see that. Or we can just make sure it smooths correctly by using an inset there again. And that part should be about done. I'm going to move on to another part here. And this shank, while the main shape is symmetrical, there are details on it that are asymmetrical, that are not the same on the left and the right side. So this is one of them. This is some sort of plate with, I think it's a fastening mechanism or a mechanism that moves the actual shank that we just modeled. It moves it up and down. because you can actually extend it further down into the earth to drag deeper ditches using the bulldozer. That's a sort of pneumatic system that can move that part up and down. That's what I'm actually modeling, creating the basic shape for the bracket. So right now I'm going to extend this cylindrical part to the bottom bracket that I'm creating right here. I want to connect these two together. Select the borders, hit bridge, and that's it. This needs to be upscaled slightly, so it's almost the same dimensions. And that looks about right. So that's the basic shape, and it's time to start adding in a few more detailings, like this nice rounding at the bottom. And now I want to perform an inset on this to get the rounding right on that round part at the front there. This looks about okay, but I think I need to select a few extra parts, extra facets to make sure that this is inset correctly. And when I perform an inset like that, that looks just the way I want it. Now this needs to be rounded, so I need to move them outwards a little bit more, just space them more evenly. And then I can perform a connect here, and do the same sort of connect over here. It needs a few more adjustments. These need to be moved in, so the spacing is the same. There we are. And now I can use the same type of bracket part to connect to this one. What you'll see is this is the sort of the top bracket for a pneumatic piston that moves up and down. And this will be part of the bracket that attaches to the piston. The top part will attach the piston back to the main shape, but it will be able to hinge. I'm deleting that inside, moving this up slightly to create this sort of double-sided bracket thing. You see, reusing this part is just a lot quicker than creating it from scratch again. To get rid of these silly little vertices that's in the center. Apparently there's still a small problem here. Need to try and weld everything. There we are. And then I can space these apart. Move these down. And this looks about okay. So now I want to create the axle that'll hold these things together. Need to lower the number of segments and everything. And there it seems to sit nicely. We don't need like 18 segments. 6 will do for something this small. Or we're just going to needlessly add to the poly count by over detailing simpler objects. These parts are done. All I need to do is take this nut and use it on the bottom bracket to show that it's bolted onto this bottom part. Scale and move. And then copy it to the other side. Then attach them. Attach all these parts. And I just realized that I forgot some of these here. Like that. Okay, so this piece of bracket looks okay. Time to start creating the rest of it, which is the cylinder that sits between it. Now this looks really big, it's a little bit too big. But first we need to extend its length. Okay. So yeah, it's probably gonna look most like the reference if we keep it this big. So seems like it's directly attached to that bracket at the top. There's some detail on it, like this little bevel part here. Just getting that around a bit. And then once again, there's a sort of bevel part over here. Sort of extruded part, there we are. So that's the pneumatic piston, in which the gases or pneumatic liquid will push things apart and actually move the shank up and down. Looks good with Turbo Smooth. So I'm going to move on to create the final bottom bracket. Also, you can see there's a small little detail on one side of the part we've been working on so far, simply created from a cylinder. This is again one of those simpler details that we decide not to show anymore in the videos, and that you can instead catch from from looking at this video over here or looking at the final max file. This bracket's a little bit different. The plate's a lot bigger. It has these two parts that extrude. And we're getting the basic shape in there. Forming a slight extrude. Then moving these outward so that we can get a nice rounding in there. Move those over there to make sure that this is smoothed correctly. I'm going to perform an inset here. It might seem a little strange, but it has its reasons. Since there is actually a sort of square part on the outside here. And we need to create that first before we add the edges for the rounding on the outside. I decided also I'm not going to model this thing twice, so I'm deleting half, and I'll get back to using symmetry here. So select these, delete them, then select these edges, shift move them outwards, weld these up at the bottom there, and move that down there. So it looks triangular, but it's not exactly triangular. Like that. There's a whole bunch of new edges that need to be added due to this new geometry. There we are. Another loop. A few more loops here. Of course, a new loop is needed over there as well. Need one there. Looking at the reference, I think I can move on to attaching this and creating the connecting part in between there. Thing is also on the reference, this doesn't sit against this part at a straight angle. I'm just modeling this at a straight angle because, well, you know, that's a lot easier. I know it sticks out from this side. We have a little problem here at the bottom. You can see that's a problem with the symmetry. So I'm going back and fixing that up. So you see that can happen if you don't watch out with the symmetry. So going back here, adding this one since I had to go back a few steps. And then attaching this again. There we are, that's fixed now. I added some nuts there to show how the plate is fastened. And then there's this cylindrical part at the bottom that makes sure there's some extra detail there. This is all part of the sort of hinging mechanism. Okay, that's added. And then I'm adding this part in the center here. Adding another one over there. And this is a really complex lever slash hinge system. I'm not exactly sure how it even works. It's tough to see, but I'm creating everything I see, which is a few of these cylindrical parts that connect together. Selecting these. And there we are, connecting those together. With a sort of, once again, a sort of dog bone shape. A dog bone shape is a connecting part between two axles that need to have a sort of lever action between them. I'm opening up this inside, taking this connecting bridge, and there we are, we've closed that gap off nicely. Again, some extra parts. Alright, so we still have some more work to do on this part. First we do some insetting, and then we extrude those, and that's to give the impression that this axle is connected to the actual brackets. Then I select these faces at the bottom, and I extrude them because this part is actually a lot bigger than those two connected cylinders up there. There's this extruded part that connects to that piston that is coming out of the bracket that we just modeled. I'm going to scale them slightly together and add another edge to control the smoothing. And then I'm going to add another cylinder here. And I'm creating it as a separate cylinder because I want to model them as one piece, attach them together. But it's a bit silly to start a cylinder from scratch. So of course I'm creating this primitive and trying to align it nicely. And you should take note that I'm trying to align the segments of the cylinder with the vertices and the edges of the model I was just working on. And then I just simply add some extra edges to make sure I can connect things. Delete the inside. Actually, delete two insides. Move these up. Delete that. Add some extra edges just to make sure that the number of segments lines up, and then use a simple bridge to attach things together. And of course, the obligatory inset on the cylinder caps. Scale that outwards a little bit so we get that beveled effect, and then perform another inset to get the smoothing right. Now there's more cylinders attached to this. These are the outside plates along which this the previous part will hinge and move. And these are sort of capsule oval shaped, so I'm just taking a cylinder and scaling the two ends apart. I take these two faces and inset them to get the smoothing right, and then perform a second inset here. That looks like it's about all we need. So I duplicate this to the other side. And then I'm creating another cylinder in here. And this is how the piston, the big piston up there, is going to be attached to this part. So you can kind of guess how it works. All of these levers and hinges are moving each other. I think they pull a pin out of and into the main part of the ripper so that the shaft can move up and down. Scale that down a little bit, and then delete it. And then add some extra edges here to control smoothing. And then everything is attached together. And here, of course, I do the rotation I just talked about. So with that done, I'm going to move on to creating a few extra details for the ripper at the back. We still have quite a lot to do. We've made the two main parts. There are still some smaller parts. And so two very big important parts for the ripper are the actual pistons themselves. And these pistons are what will move the ripper back and forth, up and down, that will tilt it. So I think I'm going to do those next, and this is just how I'm starting things. Get that down a little bit. The pistons are interesting. They have an interesting shape. There's actually a cylinder that then its shape, its cross-section changes into a square, and we need to make sure we can attach those things together. So I'm just using the same thing that I used for other piston parts, the loop tools with the spacing button and then the circle button. I'll make sure that these edges are spread out nicely. Of course, I don't need that cylinder. I thought I might attach them together, but it's just easier to start from one part and move on. Then perform an inset here. Do an extra inset. Add some edges for geometrical detail. And of course here there's another sort of beveled edge. And at the front here, I just took the plate from the back, which has the square going into a cylinder, duplicated it to the front, and I'm just going to attach that over there. No reason to create things twice. needs to be scaled down slightly smaller. And then I move this against that part over there. And cap that up and then do an inset. Use connect to get an edge in there. And then we have to create a circular part at the back that will allow it to be mounted to something and allow it to rotate and hinge along this mounting ring. Also, you notice that I attached the main model to the ring itself. Why? Well, when positioning this model, I want to rotate it along a pivot point that makes sense. So that's why I attached it like that. Of course, make sure the smoothing works. Add edges if necessary. Taking this part, making it slightly bigger. Why am I starting from this part? Well, I want the radius to be the same as the part I will be attaching to, so it's just easier to start from that. Select these two, do an extrude so you can add control edges on both sides. Forming extrude on a closed loop is interesting, like you just saw me do here. Also note that I added the nuts on one side. And gotta note that this the inside of the piston, this big rod that moves up and down, it's actually a separate part. Well, why? Because in the real bulldozer, this is also a separate part, since it's supposed to move in and out when the pneumatic system pushes it. And these pistons at the top, they will tilt the angle of the ripper, while the ones at the bottom will actually higher and lower the shank into the ground. All these parts attached, and that top one should be done for now. We need to add some more details to it, but I want to get the large shapes done first. So I'm taking these two here. And why am I doing this? Well, the top one had a special rectangular cross section, and this one had a special 8-sided cross section, which is, of course, also kind of tricky. And I want this one to morph into a cylindrical shape as well. So that's what I'm doing here. So you saw I started from an 8-sided cylinder and then used connect to add control edges to the corners, and then use the loop tools again to do the cylindrical cross section in the center. Now I'm just adding the same old edges for detail. Scale this up slightly to get it looking a little bit more interesting. This one needs to be scaled down slightly also. And once this most difficult part is my liking, then I'm going to start extruding the other main shapes out of it. So I'm just using shift move here, shift scale as well. Sometimes I like using that more than extrude because it's slightly faster and it's a little bit more hands-on for tweaking. While when you use extrude and inset, you have a spinner to slide up and down for tweaking. Well, now you can actually use a gizmo, which I think is still a little bit easier. So I'm just doing this differently because, well, it makes it more interesting to look at, and I prefer to switch methods if both of them are equal. So again, you can see me creating the main piston here, adding control edges. Then here I'm showing you how I add the nuts, but you can basically imagine I'm just adding one and using the array tool over the 360 degree with 8. And for this one, I use the array tool. For the top one with the square, I didn't do that because they're just 4, and spacing those is pretty easy. While spacing 8 nuts along an 8-sided cylinder is a little bit trickier, and I prefer to use the array tool for that. A slight rotation to get things in the correct position. And then I'm taking this same mounting part, moving it down, taking the same inside piston, moving it into position as well, Once again, no reason to create these things twice. I mean, it's pretty easy to just copy them and then move verts around a little bit. Then I move this one into position, so it just nicely lines up. Then I'm making sure to attach these two parts together by linking them. Not really attaching, linking, because I want to keep them separate, but they still have to move each other. So that later on, if I will rotate the main piston, then that extra one will move along. This is a funky little mounting part. It's sort of the same as that protective part on the shank at the back, but the difference is this one isn't protective. It's a special mounting plate to which most of the pneumatic cylinders are attached. And I'm just using the same way here, creating the main cylinders, creating the connection in between, and then tweaking the vertices to get things right. All of that trying to work in 2 dimensions only. So I move those back, and that's how it actually attaches. It's attached to the frame like this, and then the big pneumatic pistons are attached to this plate. You see that things aren't lined up yet, but I'll get to that. Getting all of these things lined up is, I think, this is the most difficult part in the bulldozer, to get all the single parts to work together and to cooperate nicely. And to be honest, it would have been better if we'd have gone further with the block out here, but we can make things work like this. I mean, they're still separate parts. It's not like they're all plates that have to fit nicely together. There are parts that hinge, and if we were to create an animated game object or something of this, then you'd have to keep things separate and have to be able to move them afterwards still. So, okay, so we move that. These two look all right. Change the color. I think that looks good. And then, as you can see, I'm just rotating these along their correct pivot points to get them to line up. First, I rotate the pivots into the correct position, and then I take the actual objects and I move them until they line up nicely with their attachment position. See, this is kind of different from how you'd build things in real life, but in 3D it's possible to cheat, so looks about okay. I think that sits too close to the mounting bracket, so I need to move it out. I think it wouldn't be possible to move it anymore. It can't move any further down, so all right. Now, one thing here is, I've been talking all this time about how this is a pneumatic system. A pneumatic system is a system that works with pressure, and this pressure is distributed along all the components using pneumatic fluid, which is a special fluid that reacts very well to pressure, which means it doesn't boil very quickly when it's put under pressure. But this fluid needs to be spread around, and for that, a lot of mounting valves and tubes that distribute this pressure among all the parts are needed. And so this part I'm creating here is an important part of the pneumatic system. It's a sort of valve slash mounting point where the pneumatic wires are and the pneumatic hoses are attached to. So the hose is attached to this, and this little piece actually feeds the pneumatic fluid into the piston. And this shape isn't really hard. I'm just going to create one of these, and I can use them multiple times then, especially at the back here, since this is the most complicated pneumatic system. You've seen me create it at the front also for the big piston that moves the blade up and down and back and forth. This system has slightly different valves and attachment brackets to perform a small selection of bevels here, just a few. Change the color. And you should note that I added a few nuts to it also. I added 4 of those nuts, since you should actually be able to take this system off. I'm going to align it with this part. And of course I need to rotate this in local space. Move it into the correct position, move it down. It sits about there. Now this part might have benefit from might have, I'm saying, I'm not sure if it's worth the effort, might have benefited from modeling it all as a single piece, but I decided to refrain from that since it would have taken a long time for a very slight benefit, in my opinion. You could actually apply what you've learned so far and try and model these circular parts as a single unit with the pistons that I'm now just shoving them into. So I'm moving these two around. As you can see, there are actually two mounting points for the pneumatic wires, and they point in pretty strange directions. And once we have that done, you can see that I duplicated that part to the center because I think I might use it again. So what I'm doing here is I'm creating another armored plate at the back of the bulldozer. As I said, lots of pneumatic systems. They put some extra armor to protect quite a few of these parts. So I'm just modeling this extra plate. Good thing about these plates is there's actually a huge amount of detail behind them, and these plates cover that up, and they prevent us from having to model all that detail. And it definitely would take a lot longer, so it's good that we can skip a little bit of work there and take the easy way out here. Just adding the control edges, then using the symmetry, change the color, and there we are, that plate looks about right. Now another part behind here is, I think it's the back of the transmission of the bulldozer. Sort of this 8-sided cylinder as well. Not exactly sure what it is. We're trying to keep this simple because most of this will be in the shade, won't be very visible, so just keep it like that. Right, so I'm chamfering these so we can get the correct smoothing there. And performing another extrude here, but only with a select amount of faces. As you can see, I selected only 2 out of 3 of those faces and then extruded them. Then I'm performing connect over here. Get the smoothing correct. And I'm deleting 1/2 because I think the modeling I'm doing here is going to get a little bit too complicated to actually justify having to do it twice. Using cut to match these things up, and then adding a few nuts for a cheap and quick way to increase the amount of detail. And it matches with the reference, so that's nice. So we copy those down, move these around, and then I'm simply going to attach all of them. You do this, you gotta make sure you don't select the wrong part like I just did here. Make sure you don't click too fast and try to be accurate when doing that. It can be quite troublesome when you accidentally attach a 1 million polygon part to an edit poly because it pretty much collapses the turbo smooth and makes things a lot heavier on your computer, so you want to avoid that. One thing that bothered me a little bit here is this part was slightly open. As I said, when you have lots of interconnecting parts, you want to make sure that there are no open holes where you can see through. So what I'm doing here is an attempt to fix this and close things up so that you can't see through anymore and there are no open holes left. Performing an extrude here to close that up. And it doesn't really matter that these parts fit together really well. As I said, you can get away with doing things slightly quicker and sloppier here because it will be hidden in the shadow and it will barely ever be noticed. I think this is a better way of doing that. There we are. I'm trying to find out the best way to match these things together and close things up. And side profile. I decided to actually simplify things a bit, make it a little bit more straight. There we are. Okay, that looks pretty good. Now this was an interesting part also. I felt like I needed to add it. There were these these cool looking canisters that extruded from the back of the bulldozer. My guess is they're part of the hydraulic system also, but they had a nice little shape, and they definitely drew attention to a part that's otherwise not very interesting. So I just added them in there. As you can see, it was just a cylinder with some simple modeling. Now, important part here is I'm using splines to add the pneumatic hoses that distribute the pneumatic fluid along the entire system. I try to get these hoses down with as little control points as necessary. I'm only using a control point at the ends and where there is a curve. I'm only using one per curve. Don't go and add too many. It gets really difficult to control. You want to keep this simple. I just added one extra here because it's becoming obvious that I can't get this to work with such a low amount. But try to start simple and make it more complex when you move on, as you should do with pretty much anything when modeling 3D. Don't make things over complex if you can do it simple first. Also, I'm trying to pay attention to get the bends and the curves in these hoses. I'm trying to get them natural, so I don't want them to have any really funky and strange twists and curves that look like they shouldn't be there. I'm trying to think of gravity, of the rigidness of the material, and in general just trying to match the reference. These hoses are pretty strong, so it's not like they'll be hanging down like rope. I'm pretty sure that these will be braided with metal. They braid these hoses with metal on the inside, so there's like a braided metal cover, and then there's plastic around that, plastic or rubber. It makes them stronger and more resistant to pressure, so they don't burst, and so they last a lot longer. Requires less maintenance. Trying to get this right. Also, you can get a sneak peek of this little panel I made at the back there. It's just a box with a few cylinders that I moved in there, and I also used that pneumatic valve attachment part. It's a really simple part, and it just has 4 distribution parts for each side, so there's 8 in total. 4 left and 4 right, and 3 of them are pointing outwards, 1 of them is pointing downwards. Now you can see here, this one's a little bit more tricky, as in real life, the hose also does this really crazy bend. So you just need to put a little bit more, well, a lot more care into trying to get the curve natural here. You just see me tweaking things around, trying to get that right, trying to make it feel like it's really connected in a believable way. Don't go over this too lightly because it's a pretty important part to get things to look interesting. These hoses are an easy way to add detail, and the only control you have over them and that you should have is the Bezier handles, so just do your best at getting these believable. Look at that, just in this overview it looks a lot more interesting already. And once I've created a few, I just duplicate them to the other side.